So, welcome everybody. Thank you for joining us in this presentation about the new features in the new info version. That means version 10. My name is Mohsen Miri, and together with Thomas Whitmer, who is our technical support engineer at Info team, we would like to present you the 10 features you should know about Info version 10. We hope you enjoy the webinar, and we would be very happy to answer your questions at the end of the webinar. Tom.
Thanks, Mohsen. I'm looking forward to show together with you the new functions of version 10. During the webinar, we will have some polls and would appreciate if you could participate in them during this webinar. So I will start at the beginning just with one. And the question is, for example, where would you use high overlap projects in your production? So I hope you can see the poll. And for us, it would be just interesting to see which of these products, where would you use high overlap? And therefore, just that we get an idea. It does not need that you have already a project, perhaps also in the near future, where you think this would make sense to run here aero triangulations or multi-head system projects. And just that we get an idea also where this would be an interesting product, and in this case. So we will just run a little bit longer the poll, and then we will show you the result so that you also see. I'm sure you're also perhaps interested how the other people are here working on these products. And I just give a few more seconds for the voting, and then we will then present it here.
I'm looking forward for the results and the participation of the attendees, and that could be really interesting to know what are the strategies and projects are going in different areas and regions.
Okay, so 5 more seconds, and then we can just show it to everybody. So, okay, so thank you first of all for the voting, and let's take here a look, and then we can here share it now. I hope you can see it here on your screen. So this is now the result, and let's see, 88%, so most of you for true orthophotos, 65% for meshes. This is for me surprising, and for you, Mohsen?
Yeah, actually, I was awaiting that the two orthophotos would be the majority, and surprising is the 65% is considering the meshes and city modeling. That's really interesting.
Okay, so thank you very much. We will then also continue in this case here during our webinar with a second poll later on. But let's continue with our presentation. Mohsen, I heard you want to show us the vision of the info team, and music will be somehow also a topic in this presentation. Is this true?
Yes, Tom, as you know, an image can replace thousands of words, and I was thinking, how can I demonstrate the vision of info team at Trimble in just one image and just share what we are thinking and what is our vision. As you can see, I would say the message is orchestrating the precision. That means we want to accompany and help you as users for transforming the pixels or raw data to the final products, for example, point clouds and true orthophotos. As you know, in any orchestra, you need different instruments to have a good play. That means it is our vision to support different sensors in the market, independent if they are our partners or they are our competitors and so on. We are focusing on supporting all available markets and interesting market sensors and to provide the available or possible features. The second point in an orchestra, if you want to play successfully, you should be able to play in different scales. It is our focus to work on scalability. That means different project sizes should be supported. We should provide our user different workflows and different processing units. The third point of the fourth point I want to mention in this image is a successful piece or piece of music which is based on melody, harmony, and rhythm. That means we are here for you for providing with strong modules in info portfolio or info suite, which is so-called our melodies. We will provide you seamless workflows to keep on being the pioneer in harmony and help you to be more productive and stay on rhythm of productivity. For productivity, you need for measures and precision and also keeping on the time. Integration in different generation is also another point that should be considered in an orchestra to produce long-living melodies. That means we would like to deliver products that are updated and suited and compatible to the final or further steps of geospatial, for example, in GIS environments or in image processing, if it is in, as an example, e-cognition as a product under Trimble, or other partners, for example, ArcGIS and so on. Now I would like to pass on to Thomas for beginning with the first feature.
Thanks, Mohsen. So the first feature that we want to show is the new matching strategy. So, and this new matching strategy that was introduced is mainly for highly overlapping data. This is very typical, of course, for multi-head systems, which will be, you will hear today a lot, this topic, but also for highly overlapped projects, like, for example, 80% flights. MatchAT always offered for many years a very stable and well-working workflow worldwide for error triangulation. And I think what was our strength was always also using different photogrammetric camera sensors from different vendors. So always to stay flexible and to offer our clients this flexibility to integrate new sensors that entered the market. And therefore, our goal has been also now with version 10 to integrate the possibility to run these multi-head systems in a more fluent way in this workflow. One of the main challenges for multi-head systems or highly overlapped projects is the capability to get tie-point matching, where a single tie-point is measured within these different cameras, or all these cameras based on a station or a system. In info, when we talk about system or station, we will use in the future very often the word platform. So where all these different cameras are built on top and they are looking into different directions and they are exposed, synchronized at the same time. Another thing that also was the challenge now with the integration of this was these mass amounts of observations. In multi-head systems, it is very common that a single tie point can easily be measured in 70 or more images. So the block can easily have millions of observations. And this is also something that we wanted to handle now with the new version 10, and to be able to handle these highly overlapped projects more efficient with a very high performance. And so this is something where we now achieve that we can be 2 or 3 times faster in processing these large amount of data and also to handle them in a good way. So MatchAT is now offering this new matching strategy that can get tie points measured in different cameras and also handle this mass amount of observations. The function that was introduced is integrated within the common workflow of MatchAT. So this is something I think this is nice for all the people here using MatchAT. It's not that you have a new software that you get. It's not that you have to purchase a new software. So it's if you have Match AT, if you worked with Match AT, then you will feel very comfortable also to use this functionality. And it's part of the frame triangulation tab. Yeah? So whoever works with Match AT, if you look at the screenshot, then you can see here on the screenshot here the strategy tab. And here now we have the default setting, but also we have the optimized for high overlap strategy. And this is really just as if you would run Match AT in a normal way. And we will then add here these parameters to run this process. I hope this will then be also intuitive for our clients and that they automatically then will be using the correct parameters to run this, and also that the project configuration will then make sense. So this is the first function. And so Mohsen, what is the next feature that you want to present?
So the second feature is so-called automatic tie-point refinement with least square matching. During the tie-point extraction in the matching, there could be, for example, some points those could not be measured in all images because of, for example, the processing was made in Subblock, or sometimes the point could have been measured in all images, but they are eliminated by the blunder detection in Match AT. For example, if you can see, I show you, this is just a screenshot of a block. On the left side is the border of the block. It is actually expected that the matching might be critical, but inside the block, there should be, for example, some parts because of the texture and so on, needing for improvement for the tie points and connectivity of the tie points. So what does it mean, or what is the request of the users? If the user would like to improve the quality of the tie point, they should start the processing again or anew from the beginning. And this is time consuming and losing time. It is not that comfortable. What has been done in Match AT? Automatic tie point extraction or refinement would be refined in this feature. It improves the block topology. That means the tie points that are available or measured could be transferred, tracked, or scaled in the images those they are not found or they are missing. So there is no need to start the processing from the beginning, but post-processing, or better to say, post-matching would happen in this feature or using this feature. For increasing the quality of the tie point, for example, if you have for one tie point 6-fold or 10-fold images, you can improve it or densify it to 30, 50, 70 or fold or more. That means improvement of the block topology. Another feature I would like to introduce, which is a very, very important point in multi-head workflow, is an advanced feature in InBlock. Why it is required? The improvements in the multi-head systems leads in stability of the platforms. The question from the users is, how can we use this information, that means the configuration of the stability, in the bundle block adjustment? The question can be answered in this feature, but another question is, how can we transfer the parameters of the weak oriented cameras in one station to the better oriented heads? And how can we compensate these orientation parameters for just one platform? In this feature, which happened in Match AT, you will find multi-head calibration within block, and you can use the parameters, for example, the standard deviation offset, to defining the reference sensor and the configuration of the platform as additional information for boundary block adjustment. As I mentioned, it is an advanced features in InBlock, where You can use GNSS IMU observations as configuration information for driving automatically a multi-head platform information. So optionally, you can use, for example, the features before which were available in Match 80, which means the calibration within block, like usual for separated calibration for each head of the multi-head platforms. These features allows a drift correction on the platform, which leads to higher accuracy and more stability in orientation. And this feature offers a better model for adjustment in the multi-head systems, and we recommend very, very much that to upgrade for such projects and using these features. It is time to start a second poll or a second question, and let's see what happened and what would you answer.
Thanks, Mosen. The question that we have for you is, as you can see, what is the largest number of images processed in a single block that you have faced? So for us, it was really to see what are these largest chunks of data that you were working on, and just to get a feeling here about this size. You know, I'm working in the support, so typically we get more the issues with large blocks. But are they still smaller blocks around going, or what is a common chunk of size that you are using? And again, we will do it like before. We will just leave here for 1 minute the poll, and then we will take a look here at the result and see then. Let's see if we are surprised or not. We will see this. So 5 more seconds, and then we close it now. And thank you very much again in this case here. So let's take a look and share it.
I think the user are really interested to know you informed about the new matching strategy and performance, and the main concern of the project manager is how to manage the blocks.
The next feature we want to talk is about subblock definition. It's of course, you see the topic that we are covering here is handling these large projects coming from these highly overlapped projects from multi-head or also from Nadir. And these large blocks, they are of course a challenge for the error triangulation and also for the tie-point extraction, and also of course afterwards the adjustment based on these large amounts of tie-points. And as we have mentioned in the previous slides, we spend a lot of effort now to handle large blocks more efficient. And our goal is always to strive to have the complete adjustment. So that means really having these 20,000 to 50,000 images and adjust them as a complete block. Still, in the meantime, we also want to offer practical solutions, which means if customers have blocks larger, let's say 100,000 to 200,000 images, then still you need to handle them, and then subblocks are the solution for this. So what we did, we updated our options for the subblock generation. Besides the project editor, where we can do also like previously in the version before the subblock generation, we added into them also a selection with the base, with the heads of the cameras. You can also make here subblocks in the project editor based on the head. But we also got feedback from our clients that would like to have subblock generation also more in a graphical way, or also based on some statistics, or also based on some weak areas. And therefore based on critical areas where the matching failed, or also areas where the standard deviations in a block did not work fine, or perhaps also looking at images that are all looking north or south. And therefore what we added now is generating subblocks in the photo measurement tool. You can see it here in the graphic here. So in the graphic, we can here in the photo measurement tool, we have also a statistic window, if you are aware, working with our software. And then you can sort in the statistics, for example, for omega. And that means all the photos looking then in this case to east or west or south or north can be here then therefore selected. Then you select them here. And then you just easily press the plus button, give the subblock a name, and then you generate it in the photo measurement tool based on the viewing direction a subblock. You can also, of course, graphically just drag a polygon, or you can also, in this case, with the polygon, you can, of course, underlay the standard deviations of the photos. You can underlay only 2 times connected tie points or only tie points that are weak. Or in this way, I think there are many options how you can now easily, based on a critical area, select a block for a subblock, or just as common on the sensor itself. So this is an easy way to generate subblocks in MatchAT. And then, of course, you can, as you are used in MatchAT, you can run all the tie-point extraction and adjustment on the subblock, and then finally make a post-process on the complete block. Okay, so this is then the function that I was introducing. So Mohsen, what is your next function?
So as Thomas mentioned, we're offering interesting features for the project managers who are dealing with the large and complex blocks. It is a highly requested feature to simplify handling the blocks. It is not just performance, it is also managing projects and blocks issue. For example, if the user need to divide the blocks in different subblock projects and exporting without losing time in copying the parameters, and simplification is always wished, and it is also working in different workstations. What happened, we export using the export sub project, the subblocks that are generated. For example, in the last feature we have seen, we can select the projects or the subblocks and exporting. All parameters would be exported. For example, the orientation parameters, GNSS, and IMU strips, ground control points, and also the camera parameters would be exported together with these separated projects. It is also possible, if you are interested, to export the area of our boundary of the subblock. You can use exporting them, the subblocks or outline of the subblocks in shapefile format, which is available in Project Editor. But the exporting the projects or the subblock projects is available in Application Master, and going to projects, export, and also sub project.
Okay, thanks, Mohsen. The next feature is about evaluation. I think this is a thing that is quite now also a challenging part. Typically in photogrammetry, when we talk about a camera, then we talk about a measurement instrument. Yeah, so if you would compare it to the surveyor, this would be the total station. So this is the instrument that is doing all the measurements. And of course, when we talk about multi-head systems, then we are talking about 5 measurement instruments. Yeah, and each instrument or each measurement instrument creates its own amount of data. And the question, of course, then comes up, can we assume that all these 5 measurement instruments are equal of quality and accuracy? Or should we make the nadir image more accurate treated than the oblique view in this case, because there are scale differences in the oblique view? How do these different measurement instruments impact accuracy, connectivity, also the data distribution in our block? So we see there are many questions which will be solved perhaps also only in the future. Our goal is to introduce at the beginning some basic statistics in our report files to allow to compare these measurement units to each other. Yeah, so we are offering histograms in our report PDFs, and they are based on statistical histograms for the main common values used in adjustment. So the histogram allows us to take a look at these 5 different measurement instruments, at these 5 different cameras, and to compare them in statistics to each other. So I want to show here an example for one of these statistics. And in this statistic, when we go from the left side to the right side, then we see here the values 43, 87, 131. So these are the amount of tie points created in images. And when we take here, for example, this yellow line here in the middle of this graphic, then we can see this is now about 263 to 307 tie points in one image. And if we go along this line, then we hit here this red histogram curve, and this one represents our nadir head. So that means in the nadir image, we have about 300 photos that have around 260 to 300 tie points. And then when we hit this light blue curve, then we have in the left head, in the left camera, here 340 images existing. And no surprise, this is something exactly what we also expect. And I think this is a statistic that should always also give us. The nadir has here even more photos that have more than 439 tie points in it. We have here photos with more than 500 or 600 tie points in the nadir head. And they don't exist in the 4 oblique heads. But additionally, also we can see that these four heads, these oblique images, they have a similar, in this case, tie point distribution pattern or a different distribution quality in itself. And this is the idea of these graphics. So we want to offer statistics to compare them to each other and also to find out errors, to find out blunders, to find out where is one head perhaps not behaving as it should be in this case. The different histograms are the first step to offer statistical analysis for multi-head systems, comparing them relatively to each other. And I'm sure we will in the future, together with our clients, work on these projects and also on these multi-head system projects, and then add more and more statistic values to allow a reliable analysis of them. And I think this is the main goal from us as a software company. We want you to feel comfortable working with multi-heads, that you feel, okay, how good is my system? How good are my measurements in it? When you provide orientations to your customers or to a third party, that you can also have an accuracy comprehension of your data, and so that you feel comfortable to share it. Okay, so this is this part. Mohsen, what is the next part?
As you might have recognized from the previous slides, the user interface of the new version looks somehow different to the older versions. So one of the improvements in version 10 was regarding the usability of the software. In this regard, 2 aspects are considered. The first one is better communication of the software with the user to reach out the most important features on the menus and windows and buttons and so on. You can find it via the new style, which can be found in the languages and style setting. It is switchable to the old one as well. The other aspect is providing the operators or the users the support of 4K monitors for precise measurement on the images. Here you can see the new style on the right side and also the old style on the left side, as you can compare the enhancement on the right side on the new style is on the buttons and also the selectivity and also the checkbox and so on. Somehow we would like to communicate with the user or operator via the software user interface to pay attention, to call for pay attention. Hey, these checkbox are checked, and if you want to go to the next step, you should choose this button, and the parameter, the most available or selected parameters should be on the table for the user. Another point is supporting the 4K monitors. For example, if the user would like to work on the photo measurement tool with more precision, selecting or choosing the best quality of the monitor, you can use or you can enjoy the support of the 4K monitors for both single monitor or stereoscopic working. So Tom, what's the next feature?
The next feature is orientation exchange. We are now offering to exchange orientation information from aerial images and satellite data. We are offering now a very simple export of these orientation values. Depending from the status of the orientation, so we can either export the raw data, so that means you imported the original data, then of course you can also export this in a simple format. But also when you process data in our software, then you can also export the adjusted results. So this means for the aerial images, this would be then after the aero triangulation, then the adjusted exterior orientations. Or when you run satellite data with Submaster, then also here, when you run the adjustment, then you can also export these adjusted orientations. And to do this, we are using a simple ASCII-based format that we use for the export. In case of aerial images, this will be this classic X, Y, Z, omega, phi, kappa values that you export. In case of satellite projects, this would be the very standardized used RPB or RPC formats, which are typically including these 44 coefficients inside this RPB or RPC. How can you access? It's very simple. You go to the project editor. In the project editor, in the aerial part, you double click the frame type. Here you would see the list of all the photos. You would select them, which ones you want to export. Then you will find on the right toolbar panel an export button. You press the export button, and then you find out here the output dialog, and you define if you want to have it comma, space, or tab delimited for the output. Or if you have a satellite project, then you go to the RPC type entry, you double click it, you select all the satellite photos that you want to export. Again, on the panel on the right side, you find the export button, and then you define the output folder and define if you want to export it in RPB or in rpc.txt. So it's a very simple and easy way to exchange then orientations between clients with the adjusted orientation values. Another thing that is also included for the export is the for the true ortho photos. So the true ortho photos we already introduced in the previous version the true ortho photo export from Match 3DX using Ortho Vista functionality for the tile definition. In the tile definition here, in the previous version, we were using here the standard Ortho Vista parameters. You defined the tile size, you defined in this case the reference point, and then you counted how many tiles to east, north, west, or south. So 12 to the north, 15 to the east, and then this was then for the output. And this was very positive from the customers, accepted, but also they asked if it's possible to run the export based on a shape file. And so this is exactly what we then also introduced. So we now offer with the new version 10 to export by shapefile. So you can here switch to shapefile, you select the shapefile, and the only thing that you have to take care is that you have an attribute field in the shapefile called name, and this name field has unique values in this column, In my case here, it's here the upper left coordinate that is here, the unique value, and then these tiles here, they will be exported, use these names of the shapefile. It's very simple. You can just load it, and then the names will then here automatically be part of the output. And as before, you can still define your own reference point. You can still define the pixel size of the output, and therefore then this is then a possibility now to make it even more comfortable and more customer defined for the output of true orthophotos in Match 3DX. So Mohsen, yours next.
Thank you, Tom. As you mentioned, Match 3DX is a very attractive product for generating the true orthophotos, but it is also very powerful for point cloud generation and also 3D meshes and so on. The request from the user was always, yes, we have a very powerful modules, for example, DT Master for working with the point clouds and digital elevation model and so on. How about working on the web? Are the point clouds ready for working on the web? And this feature, which is actually a collaboration with the team Trimble Clarity, I would like to say the quality of the point cloud is so that we can publish them in the Trimble Clarity. For this, if you're using Info or, for example, US Master for UEB data, you can publish it over TBC or other software who provide the direct publishing over the user interface to Trimble Clarity, or you can export the point cloud and directly upload point clouds on the Trimble Clarity. For this, you need to access the Clarity point Trimble.com, and you can have a registration and try this possibility or this solution on the Trimble as well for demonstrating and working the point clouds on the web. So thank you very much. I hope you enjoyed this webinar.